Hello, everyone. Welcome to this week's binary episode of the Day Zero podcast. I'm Spectre, with me is Z. Before we get started, Friday this week, we're continuing with doing the Offensive Con Watch Party streams over on YouTube. This week, we'll be covering a talk by Samuel Gross and Amanda Burnett on attacking JavaScript engines in 2022, as well as Mark Dowd's talk on how do you actually find bugs. Also, next week will be the last week of the podcast as we'll be going on a summer break. So May 30th and 31st will be the last episodes until September 19th and 20th. We'd like to still do some streams and whatnot during the summer break, but we just won't be doing the scheduled podcasts. We'll also still be around on Discord and whatnot for the most part, so feel free to drop in there. You can find the link for that below the stream or linked on our site, day0sec.com. But yeah, with that all out of the way, let's jump into the Spot the Vuln challenge as always. I'll let Z get into that.
And this week's Spot the Vuln was another fairly straightforward web issue, at least as long as you're familiar with it. This time we've got a NoSQL client, the Mongo client being pulled down, and K9 Team K9 mentions it right in chat just now. Unescaped username and password in here. So yes, you can ignore the fact that this is also password being stored in plain text, technically speaking. That's not a good thing either, but not the vulnerability I was trying to showcase here. Simple issue here, you would be able to, because with PHP, you can provide an array rather than just the string that whoever would have written code like this would be expecting. Provide an array or an object, you can start providing kind of some of these special objects that would define a NoSQL query. So, like, you could say, instead of username, instead of this query being user equals whatever the username is that's provided, you might provide it like, actually, I guess password would make more sense here. Whatever account you want to get into, and then password. Instead of just providing it the password, you might provide an object with like the, is it like $any for not equals to something? So then it's just like finding the user that doesn't have this password. So yeah, I mean, NoSQL injection. You can Google a little bit more about that, but in this case, yeah, it's not enforcing the typing or checking for any sort of special characters, special objects in this case, within the actual NoSQL query, thus being injectable.
All right, so we'll get into some of our topics. We'll start off with Pwn2Own Vancouver, which took place last week. This is the Pwn2Own with the cool targets and not all of the IoT stuff, so we decided to cover the results, as we sometimes do. This one spanned over 3 days. Some cool stuff came out of this one. A lot of Microsoft target submissions, it seems. I think there was 3 successful exploits against Microsoft Teams. One unsuccessful attempt, though that did end up going through the regular ZDI process, so it seems the bug wasn't patched or anything. There was also 6 successful exploits against Windows 11, various bugs like out-of-bounds writes, int overflows, things like that. There were also some other miscellaneous bugs scattered in there, like a Firefox vuln, a VirtualBox vuln. I think 4 Ubuntu desktop chains were submitted as well. But yeah, always a bit interesting to see what types of submissions Pwn2Own has and what the targets look like. Gives a little bit of insight on where the active research is. Z actually put together a list that he showed me of all the targets and the submissions together, including the bug types, which was pretty cool. Maybe we'll put that on the website actually, just as a little summary. Gives you a nice one stop look at the landscape, I guess.
Yeah, I
One
can
thing
try and. Oh, go ahead.
I was just gonna say, one thing I found interesting here, and I don't know if it's just the way that it's worded or if they just didn't say it in previous years. It seems that ZDI is being more charitable to failed submissions this year. Um, there was multiple cases where they stated how they would be taking them through the regular ZDI process, even if the demo attempt failed. And I just don't remember them mentioning that in previous contests. But yeah, I thought that was kind of interesting. If that is a new thing they're doing, that's really cool. Um,
I don't
because
think
usually
that's too new because I do recall in past years they've talked about actually opening up some of the submissions a little bit sooner so people were or opening up the um opening up the bounties a little bit sooner so that people wouldn't hoard them for the event. So I would also imagine with that, if your demo didn't go through, they'd still accept like the bug later on as a report. Like, I don't know, I guess I don't know for sure, but I just wouldn't imagine them not having already done that.
Yeah, it's just the way it was worded in previous years. It made it sound like if your demo attempt failed, then you were kind of screwed. So yeah, it's just something that stood out to me with their results posting this year. But yeah, that could be something they've been doing for a while and maybe just didn't highlight it as much.
So,
For those in, sorry, did you want to say something there?
well, I was going to come in with a couple of things on the actual results that we had here. First, there were only 2 chains against MS Teams. One of them had 2 bugs, an injection, or file writes. That might be where you got the 3. But it was just 2 actual chains against Teams, and there were 5 chains on Ubuntu desktop, not 4. Um, One of the things I found really interesting though was the Firefox one, because the Firefox bug, this was $100,000 bounty, and I apologize for those of you watching who just saw Squarespace. For some reason, hitting escape on ZDI brings you to a Squarespace login. Um, so where's Firefox again? There we go. So they had 2 bugs for $100,000 bounty: a prototype pollution and an improper input validation. I want to know what the heck these bugs were and what they led to. Like, was this prototype pollution like, a build config or some like almost, I don't know if a universal prototype pollution would quite make sense, but like I want to know what this chain was that actually got them $100,000. Like, one of the issues with these ZDI reports is we don't really know a lot about it. Some things are like, one of the Microsoft Teams chains was an improper configuration for 150,000. Like, we don't have a lot of information at this point. But it really stood out to me that this wasn't like use after free. This wasn't like a traditional binary exploit. This was something else going on in Firefox for this sort of bounty, which I thought was really interesting. Um, One of the other, go ahead.
So on this one, I actually do have a little bit of information. Somebody linked this in an IRC I'm in earlier, but the Mozilla advisory has a bit of a summary or a description on these issues. I didn't really read into them too much, but they might answer some of the questions that you had brought up. So the prototype pollution, the description states if an attacker was able to corrupt the methods of an array object, they could have achieved execution of attacker-controlled JavaScript code in privileged contexts. And then untrusted input used in JavaScript object indexing, leading to prototype pollution. An attacker could have sent a message to the parent process where the contents were used to double index into a JavaScript object, leading to prototype pollution. Ultimately, attacker-controlled JavaScript executing in a privileged parent process. So it seems kind of like what you were speculating there a little bit with getting into the privileged context, but
Yeah, and
um,
that's interesting because I mean, completely viable attack surface within Firefox. You get in there, and suddenly you don't have to worry about quite as much. I mean, obviously, there's still like it's not quite arbitrary code execution, but you're a lot more privileged there. So yeah, that's interesting. I hadn't looked this up, but yeah, nice to actually have a little bit more details on what they were. 'Cause it was kind of messing with me trying to imagine like what prototype pollution was going to do here.
yeah, it's pretty cool because it's not super often you see browser bugs coming out of something like Pwn2Own that aren't memory corruption based. Um, and it's obviously a big boon when they're not memory corruption based because with memory corruption comes stability issues and things like that, whereas these higher level issues are a lot more reliable to exploit. So, yeah, it was kind of a standout chain in that sense.
And speaking of standout, another thing that did stand out to me were the attacks against Ubuntu desktop. Not for any crazy reason, just the fact that so there were 5 chains or 5 successful chains on Ubuntu desktop. Uh 4 of them were a use after freeze, and the 5th one was an out of bounds write and a use after free. So like just a ton of UAS on Ubuntu desktop.
Yeah, I mean, which isn't too surprising when we've looked at some like charts and statistics that people like Google have put together before. UAF is typically one of the more common memory corruptions. It's just memory management is hard in C and C++, especially C++. So
It is, but you still kind of expect to see like on Windows, I think more common or on some of these at least more common was like the out of bounds read or write rather than just UAF. Windows actually, I think there was one integer overflow there too, but oh no, it just stood out that they were all that. But yeah, like it is a more popular class. It's fair that that's the case, and it's a powerful primitive for like starting off with any sort of exploitation. So makes sense. Um, One question I did have was that they had for Safari. I don't know if this is just like a terminology change or if the vulnerability is something different than what I expected. Being on Safari and only Safari, they had an out of band right, rather than just out of bounds right. So I don't know if
Mhm.
you'd have any information on that, but yeah, it was just the one that had this out of band right, which I thought was a little bit interesting on the terminology side. OOB usually being the out of bounds, going out of band, like I could imagine, like out of band usually is going to be have one communication channel. You're doing something on another one, like maybe there's something with like the ports being used, but I'm not really too sure there either.
Yeah, I haven't really seen that like terminology used in the context of Safari or like any browser before. So
Yeah, and actually looking at who reported that, that's from the Manfred Paul, who was the same guy who did those two Firefox bugs that we were just talking about. So perhaps it is a higher level logic issue sort of thing, kind of like what we saw with Firefox. So maybe there's some,
very
but
well could be.
again, that stood out to me.
Yeah. So we will eventually see write-ups for some of the bugs that are in this post. I saw somebody in chat earlier, Obfly said, "Damn, hope we get a write-up for that." And that was when we were talking about the Firefox bug. Typically, we do get write-ups for at least some of the vulnerabilities, but they do take a while. Sometimes it could be like up to a year later. So yeah, we'll definitely be, well, almost certainly we'll be covering some of the vulnerabilities that are mentioned here. But yeah, it'll be at least a few months before anything public is available on them.
Yeah, and at least on the Firefox side, they have their attack and defense blog, which puts out some interesting posts sometimes about the vulnerabilities found. So I'd hope maybe we'll see something there, if anything. And of course, ZDI puts out such posts too. So yeah, hopefully we'll see something on them.
Yeah. Um, One thing that was kind of interesting, just from a meta standpoint, was the leaderboard. For those watching, you can see I pulled up the leaderboard. It's at the top of the page here. Star Labs came away at first with 270K in prize money and 27 points. What I thought was kind of interesting was the second, third, and fourth slots. So Pero, Masoto, and Manfred Paul. These all seem to be like individuals. And then you have Synactive at number five. But a lot of the Pwn2Owns we've covered before, there's been like a strong team drive behind them. I don't really remember covering like a Pwn2Own where so many individuals were in the top spots of the scoreboard, but yeah, I mean that's kind of cool to see too. Because we've said before about how exploitation on modern hardened targets is kind of moving to a place where it's becoming less and less viable to do that as like a single individual. Um, because there's just so much work involved and so much research that has to be done. I think we mostly commented on this on the offensive con stream last week, but um, yeah, it's just cool to see like when individual people are able to pull off some of these really complex chains. And yeah, I mean, in some cases, like Menford Paul here, like there were chains against multiple targets here. So yeah, a lot of cool work coming out of this Pwn2Own, which is nice to see considering the last couple that I remember looking at were a bit disappointing, at least in terms of like the targets that were being hit. So
Yeah, I mean, I don't want to disparage like the IoT and SCADA targets or anything too much. Like, there's valuable work being done there. It's just not quite where our interest lies. On the
yeah,
team
exactly.
aspect, I hadn't taken note of that. It's a good shout. I kind of have to wonder if maybe we'll see more of those teams though appearing over at Tianfu Cup, which has kind of been picking up in popularity over the same time as ZDI has kind of fallen.
I could totally see it. Yeah. Um, like you said, like Tianfu Cup has been kind of rising in popularity. The prize pool is also quite a bit larger, and the target selection is also a good bit larger. So yeah, that could end up being what it is. Is it's just kind of a shift of teams moving to different competitions. But because there is a bit of a conflict there, right? Like you can't submit the same bugs that you submit to Pwn2Own to Tianfu Cup, so you save them for one or the other. So that could very well be the case for sure. Yeah, I mean, like I said, not too many technical details on many of the vulnerabilities, but those will come in a couple months. But yeah, it's always good to check out Pwn2Own and just see what the landscape is looking like. Um, it's it's not a like it's not going to give you a holistic view of everything that's happening in the security landscape, obviously, but it is a good source of data for that.
No, and it's simply nice to see actually Firefox and Ubuntu being in there, being open source products. Seeing open source actually paying out some pretty decent bounties is just nice to see. And I
Yeah,
guess VirtualBox too. They're open source.
sure.
VirtualBox has been there, I think, for a while. Firefox, I guess, was there, and then they weren't for a few years, and then they've come back now.
Yeah. All right, so we have a 0 days in the wild post in the episode today. An AppleAVD overflow, and I'll let Z take this one.
Yeah, and so this in the wild one is yeah, it's a pretty straightforward buffer overflow just at the surface level. Um Effectively it has a buffer with a fixed size, so this is fixed size, buffer, and you're copying in a unbounded size. In this case, the maximum, so fixed buffer has size for 32 elements. The number, so copies these elements into the buffer through an iterator. The value used for that iterator, it's a 1 byte value, so just maximum 255, can go well beyond the range of the expected buffer. Straightforward there. And this is in the wild, so at least described as a local privilege escalation. They call out in theory here because of macOS and iOS doing thumbnailing on incoming images in iMessage. This code could be hit remotely also. But what I thought was more interesting here was just the fact that, actually, one sentence that they have in here. Despite an in-depth analysis of this issue, we were unable to find a proof of concept media file that crashed the system, even after fuzzing with the trigger file above as a template for several days. Which comes down to largely being because the overflow itself, even though you've got a reasonably sized overflow, is still within the same object. So this is just only corrupting like pointers or data within that one object, doesn't leave the object. So you can't do any heap grooming to get access to something else. You can only corrupt that one object. And it sounds like there's no really obvious targets or really easy to hit targets that just crash the program, like a function pointer or something. So you'd expect a fuzzer to get that with fuzzing it for a few days. So I thought it was interesting that it is such a subtle bug that is somewhat harder to actually detect because, with fuzzing, you want to have that crash to actually know something happened. So without that, now, there are ways you can introduce like a sanitizer that might be able to pick up this sort of thing by doing red zones between all of the elements in a structure. Although that can create other problems depending on how complex the application is. Not expecting to have any red zones in that location as it gets passed around. There are a lot of problems with doing that too, but it can be done. Obvious performance hit there, but it can be done. But I still thought it was interesting to have this one being found, used in the wild. That just has such a subtle crash. Like the fact that the fuzzer couldn't get it over several days it's quite surprising. So I don't know if we'll ever get the information on exactly how an exploit worked on this one, but it is another one of those cases where it's a straightforward issue, but probably an interesting exploit. Because if I had to take a guess here, there's probably there's almost always multiple layers going on with an exploit, but because my guess is you don't have any sort of function pointer to go after immediately, or just a pointer to an object with the function pointer. You've got to be corrupting like maybe an index that gets used later or allocated on the basis of like some size in there. Like some multi-step thing that a fuzzer would have trouble actually piecing together. Yeah, I don't know. I mean, I just thought it was interesting, and wanted to at least kind of call that out.
Yeah, so my speculation is perhaps there's some flags field or some kind of logic bug that you can trigger with this one that then yields a more useful memory corruption primitive somewhere down the line. That's the only thing that really makes sense. Um, I can't really visualize exactly what that would look like, but maybe some flags field that you're not supposed to be able to set to some arbitrary value, but you can with the overflow, bypassing some checks, and then that allows you to access functionality that was previously blocked off to you, and it's unaware that you have that access, and so you can get some useful primitives. That's kind of how I would think to look for exploiting this type of issue. But yeah,
Yeah,
I
and
mean these types of
flex.
interobject overflows are very interesting from like an exploitation perspective because they're kind of a double edged sword. Sorry, I kind of cut you off there, Z. What were you gonna say there?
Oh, I was just going to add on with like the flags thing. You can definitely kind of lead into maybe like a type confusion sort of issue, which is pretty unlike. Well, I mean, it depends on the confusion, but in some cases where you have very similar structures, unlikely to cause a crash, but could be enough of a corruption primitive. So I was just going to toss that on to you shouting out the flags.
Yeah. So these kinds of bugs are double edged, right? On the one hand, they're pretty difficult to detect. If you don't have the right sanitizer and it doesn't cause a crash, you're not going to be able to find it, which is why they speculate here that this was probably found by manual auditing. It's also severely limits what you can do with your exploitation, like you're limited to whatever is in the object. On the other hand, though, it could be very nice for exploitation because where you're dealing with fields inside of the same object, you don't have reliability problems. You don't have to rely on the heap state being in like a certain place. Um, it's also a more subtle bug and thus might live longer. So yeah, I mean, there's obvious downfalls to this kind of scenario, this bug scenario, but there's also some major benefits too. So if you could take advantage of it, this would be like an awesome bug for exploitation.
Yeah, I mean, it's really easy to say it's an awesome bug on that basis, but we really don't know what it led to either. But I totally agree. Like, when you are able to do a corruption without leaving that same object, it does lend itself to more stability. So, I mean, I agree, but we also have no idea, uh, kind of what this really led to or how this was abused. I mean, I guess we could maybe look into the structure and see what comes out of it, but that's too much prep work for the podcast.
Yeah, I was mostly just trying to emphasize there, like if it is able to be taken advantage of, it would be awesome. If not, then obviously that would suck.
Yeah,
But
well, I mean, this
yeah,
isn't in the wild thing, so presumably, yes, it was taken advantage of and could be taken advantage
presumably,
of.
yeah. All right, so we'll get into our last topic here, which is an unbounded memcpy bug in Parallels Desktop, which was detailed by Ret2 Systems. Parallels Desktop, for those who aren't familiar, is basically virtualization for Mac OS. It's a well-known application for that and a very popular one. As such, it's a pretty interesting target because it's an avenue for VM escapes from guest to host, which is what this chain of bugs or exploit facilitates. This was reported to Pwn2Own last year. Unfortunately, it seems that this year, Parallels Desktop was dropped from the list of targets. Doesn't really seem to be any like clear reason for that, but like Z was saying with Firefox earlier, it might just be one of those things where it drops off for a year or two and then comes back. But yeah, so the post starts off with a recon section talking a little bit about what Parallels Desktop is and identifying the attack surface, mostly focusing on the guest tools and their host side counterparts for things like shared clipboard, shared folders, drag and drop, etc. And after some digging, they discovered there's basically 5 kernel modules that are responsible for implementing these functionalities. Um, PRLTG or Toolgate, which functioned as a dispatcher basically, where it listened for opcodes and dispatch handling to other services. Um, PRLF for networking, FS for shared folders, freeze for suspend and resume, and vid for video. They reversed the toolgate request handling and mapped opcode ranges to C++ handler classes. And the one handler that's relevant for these vulnerabilities is the hex 8050 opcode handler, which is handled by the TG20 OTG impl class, which basically acted as a proxy for OTG opcodes. They suspect OTG stands for Open Tools Gate, but it's hard to really confirm that. The first bug, dubbed Mega Smash, seemed to be directly in the proxy code and was an integer overflow. Basically, when allocating an array for the qbyte array, which is a Qt core object, they add 1 to the user provided size, which, if the size is already a max value, will wrap around to 0 for allocation. That allowed them to corrupt adjacent allocations, including inline fields when the large value is used for the copy. This is ultimately a wild copy, and obviously, such a large copy will cause an exception, especially since they note there's a read only mapping adjacent to the data section they have the overflow in. Interestingly, though, this turned out to not really be a problem, or they were able to get around it, rather, because parallels will register exception handlers for bad excess, bad instruction, and arithmetic. As you can kind of expect, it is doing virtualization, so registering its own exception handlers makes sense. And it's possible to trigger a fault in the exception handler thread so that it won't respond to the exception raised by the wild copy. The way they did that was they used the wild copy to smash a pointer to the exception ports. So basically, they exploit the wild copy twice. They smash the exception handler so that the exception can't be caught, and then when they exploit it the second time, they don't have to worry about the exception being raised because nothing will happen anyway.
Didn't they corrupt the Sorry, so there are 3 bugs here. There's the Mega Smash that you're talking about right now. There's an
Mhm.
information leak. I'm sure I'll get to that in a moment. And then there's another pointer, right, that they have. I believe that's what they use to corrupt the exception pointer. They use that third one because that gives them a pointer right. They can write that anywhere. So they're able to kind of selectively target specifically those exceptions. Yeah, actually, I just pulled it up here too on screen. They use bug 3 to corrupt the pointer to the exception ports.
Okay,
So they use that
apologies.
third bug to prevent the second bug's crash from actually executing, because when the exception handler thread gets an exception, it's going to go and tell the kernel hey, I've got an exception. Kernel suspends it and then passes the exception off to the registered exception handler, which is that very thread, and it's just going to wait forever. Anyway, I'll
Okay,
let you go on though.
yeah. So apologies. I didn't realize it was for some reason I thought it was the first bug that was used for that. Because there is the third bug which I was going to go into, but they kind of stated that the way they were trying to abuse it didn't really work out, so they didn't pursue that path. But yeah, you're right. Sorry, it was the third bug that was used for smashing the opcode exception pointer. So yeah, good call out. So yeah, they had using those 2 bugs, and I'll get to that third bug in a minute. Um, they were able to get memory corruption. Obviously, ASLR is present here, so they had to have an info leak, which is what the second bug is. They found an info leak in the OTG opcode 10 handler for fetching configuration settings. The 2 setting, which is labeled as OTG get disable win7 logo, has a bug where it'll resize an output qbyte array to hex 90, but it won't actually initialize the data in those new bytes that it allocates. So in this case, the original buffer was hex 20 bytes, and thus hex 70 bytes gets leaked, which could leak a bunch of heap and text pointers, which is obviously very useful. The third vulnerability that Z alluded to earlier, that was used for smashing the exception handler code, is opcode hex 8304 for the C drag and drop base. There was a stack overflow vuln. As a guest supplied string would get read and ultimately copied into a 1024 UTF-16 character buffer, and they would use a null terminator to determine the length of the string, but it's possible for you as the guest to just not pass a null terminator, and so the size can end up getting calculated as larger than the buffer whenever it would encounter one from stale data on the stack or something else on the stack, which then overreads when copying the message, copying the string to a message on the stack. They didn't end up managing to take that to code execution on its own. They wanted to see if they could corrupt a return address or whatever to get easy code execution, but they always ended up encountering null bytes before they were able to reach something useful, so that didn't end up working out. But it was useful for full chaining because, like we were talking about earlier, it was used to smash that exception handler pointer.
Yeah,
So
well, so they did overwrite that exception, the exception port pointer, using that. So what this one actually gave them was basically an arbitrary write primitive, because they would go, in this code here at the third annotation there, they would effectively be able to overwrite this message worker pointer. It was this overflow would generally give them just enough room that they'd get to overwrite that on the stack, which then they can control where it resolves to, causing this. They would have an uncontrolled value, or the value of whatever rec is this pointer, this TG rec pointer. They would be able to get that written wherever they wanted, which is what they used to actually snipe out the specific ports pointer. So not quite smashing yet, but ultimately, or at least, I don't know, I guess that's maybe a terminology thing. I tend to use smashing in the sense of like overwrite from large overflows to overwrite one particular data versus, in this case, they smash the worker pointer, leading to the arbitrary write or uncontrolled arbitrary write.
Yeah, I think that's just a bit of a terminology difference. I use
Yeah,
smash pretty liberally,
fair
so
enough. I totally get it because you're corrupting it. You're destroying the original value. I mean, fair enough. I realized kind of as I was talking that might have just been different terminology.
yeah, all good. But yeah, all around, very interesting chain. I always love seeing exploits in like virtualization software because they're really complex pieces of software, and they're not really looked at as much compared to like browsers or operating systems, for whatever reason. Probably just because they're typically more like closed source. There's a lot more reversing involved and more of a barrier to entry in general. But yeah, cool attack chain, showing the value of like different types of primitives and different bugs that you can chain together. Um, and yeah, I mean, the pieces all fit together as one of the headlines towards the bottom of the post state, and yeah, they were able to get the exploit working, and they got a $40,000 exploit out of it for Pwn2Own 2021. So
Yeah, I really like this one, and oh no, I love when you mess with the any sort of exception handling, error handling, any security checks are another place. I love seeing the bugs when you're able to abuse those systems. Like in this case, being able to effectively disable the error when they have that bad access, or the exception when they get that bad access. I don't know. It's just a fun thing to see happen. Um, yeah, I mean, I love to see it. I know I've said that. I feel like I've said that quite a bit over the last few episodes, but I think we've had some really good exploits recently. So I'll just say it again.
yeah, one last thing I'll call out before wrapping it up. For those interested, the exploit code is public. It was posted on the GitHub, so I just kind of brought that up on the stream. But yeah, the exploit source code is there, so you can play around with it if you want to, or try it out. Um, I when people ask like they want to get involved in the exploitation, they're not really sure where to start. One of my like go-to recommendations is to look at existing exploits and play with them, or maybe try to re-implement them. So this might be a good opportunity for that if somebody's looking for something to do. So yeah, figured I'd just give that a quick shout. Other than that, though, that's basically all of the topics that we have for today's episode. So Z, unless you have any last minute things you want to mention, we'll go ahead and wrap it up.
No shoutouts this week.
All right, cool. So that's everything that we have. Thank you, everyone who tuned in. The VOD will be up on YouTube and Spotify and other platforms tomorrow. Remember to follow our Twitter and join our Discord if you want to get involved in the community. Um, Another reminder that we will be streaming on Friday for the Offensive Con talks. We're going to be covering attacking JavaScript engines in 2022, as well as how do you actually find bugs. That'll be at 6 p.m. Eastern, 3 p.m. Pacific on Friday. And then next week will also be the last week of the podcast for a summer break. So 30th and 31st will be the last episodes until September 19th and 20th. But
And
yeah,
the
with
offensive con stuff, that's going to be over on YouTube, by the way.
yeah, yeah, that's important to highlight. You won't be getting any notifications on Twitch for that. So yeah, just keep a lookout on our other feeds and stuff for that. But yeah, with all that said, we'll be back next week. And until then, take care.